Alright guys, welcome back. So in this video, what I'm gonna do is I'm gonna dive a little deeper into the time value of money and talk a little bit about something called the future value. That is, how much money does every dollar worth at a certain time point in the future. Okay, it is determined by a lot of things. So we're gonna look at these one by one. So first thing first, let's try to answer this question. If you have a dollar and you can earn a rate of return of 20% in the next year, how much money will you have in a year, right? A year later. So we need a, we need a timeline, right? So like this. So from time 0 to time 1. So we begin with investing your $1 and you're gonna get a 20% return here, right? So in the end, how much money are you gonna have? Again, you're gonna absolutely have your principal back, and then you're gonna have the interest, the additional return you're getting. That is, for every dollar, you're gonna get 20 cents, right? 0.2. So this is exactly 0.2. So in total, you have $1.2. Okay, how much money are you gonna have? You have $1.2. So this is the basically the future value. So as you can see, the $1 today, okay, can become $1.2 in the future if you can invest at 20%. So the calculation of time value of money, to calculate the certain amount of value at a certain amount of dollar worth at a certain point in time, really requires you to know the return over this period. Okay, so what if you have $100? What if you have $100? If you have $100, we'll also do the timeline. So we begin with $100, and in the end, you have $100, which is the principal, and you're gonna have $100 times 0.2, which is, for every dollar you're getting 20 cents. For every $100 you're gonna get $20. So in total is 120. Okay. So if you have $1 and you can earn a return of 20% in a year, and then in the next year, okay, so we're gonna have a more complicated timeline where we have 3 time points. Today, which is here, a year later, which is here, and 2 years later, which is here. So in the first year, we're gonna get 20%. In the second year, we're also gonna get 20%. Okay, so how can we do it? So what you can do is we can try to replicate what we did here and here. So basically, we just need to know how much money we're going to end up with at the end of year 1 and repeat everything to the end of year 2, right? So we begin with $1, and a year later we're going to have $1.2, right? Because this is $1 principal plus 20 cents of profit. And 2 years later, how much are we going to have? We're going to have this 1.2, right? Which is the principal here in the second year, right? At the beginning of the second year, we have $1.2, and then we're going to earn a 20% return on this 1.2, right? So this is 0.24. So in total, we have 1.44. Okay, so in total, we have 1.44. Okay, so let's look at the next one first. If you have $1 and you earn a return of 20% next year, 20% the year after, and 20% after that, then how much money are you going to have? So we have a timeline again. So we're going to have 0, 1, 2, and 3. We do not have 3 time points. We have 4 time points, right? So we have 20% in the first year, 20% in the second year, and 20% in the third year. So what are we doing? Right? What are we doing? So we can still do the same thing. In year 1 is -1. In year 0 we spend $1. At the end of year 1 we have 1.2. At the end of year 2 we have 1.44. At the end of year 3 we're going to begin with 1.44, which is the principal at the beginning of year 3, right here, the beginning of year 3, and we need the 1.44 times 0.2, 20% interest. This is 0.288, right? So in total it's 1.728. Okay, so this is the ending value. Okay, plus. Okay. All right. So, do we have any patterns here? So it's like here, here, and here, and here, right? So can we do anything to make this process a little easier rather than we have to do it year by year, right? So if you look at the first one, what we're doing is that we're using the initial amount, which is $1, right? Plus this $1 times 0.2 to get 1.2, right? So this is how it worked, what we did, right? So I want to give some symbols to these. So this initial $1 is our present value. So that's the amount of money we have right now at the moment, the present value. Then I want to plus the same present value, the current money, times the return, times R, right? So this is equivalent to PV, the present value, times 1 plus the R, okay? So initially we have $1, which is the present value, and then we have 20%. So $1 times 1 plus 20% is $1.2. Okay, the numbers match. And what's the intuition again? So this is basically saying for every dollar you're investing, you're gonna get $1.2 in the end, right? Try to recall what you watched in the last video, where we say the way you can interpret a return is 2 ways. Number 1 is you can just interpret as the percentage of your dollar profit of your initial investment, which is the present value in this case. And the other way you can do it is you can think about, okay, so for every dollar I invest, I'm going to get a certain amount of money in total in the end. And then if I subtract 1 from that number, I get the percentage return. So here it's just the reverse of that calculation. So we begin with $1, and for every dollar we are investing, given a 20% return, for every dollar we are investing, we're going to end up with $1.2 in the end, which is 1 plus 20%. So if we're investing $1, we should end up with $1.2. If I want to scale this up, we can look at the second slide, the second example, where we have $100 to begin. So basically it is 100 plus 100 times 0.2, which is 120. So the initial investment present value is 100 plus the initial investment present value times a rate of return. This is equivalent to PV times 1 plus R, which is 100 times 1.2. Okay, so what does this mean? This is basically saying for a 20% return, right, when R is 20%, so I'm gonna write it, so 20%. So for a 20% return, when R is 20%, for every dollar you invest, you're gonna get $1.2 a year from today, right? So for every dollar you invest, you're gonna get $1.2 a year from today. So when you invest $100, you're gonna end up with $120. Okay, so this is the this is why we cared about the intuition of return earlier, because we need to make sense of the future value calculations. So in this case, if we try to complicate this a little bit more, so we begin with PV, and we're gonna get red, and we're gonna get PV times 1 plus R, right? So this is 1.2, right? This is 1.2. But what about this 1.44 then? What about this 1.44? This 1.44 is essentially just a repetition of this process, right? So we're gonna do this again. What we're doing is just PV times 1 plus R times 1 plus R. Okay, right? So this is PV times 1 plus R squared. Okay, so this is the PV times 1 plus R squared. So if I want to raise this to the power, this is essentially PV times 1 plus R to the power of 1, right? So do you see any patterns? If you try to look for what's here, you should be able to connect these two, right? And these two. Right? So you're going to use PV times 1 plus R and be able to raise it to a certain power, raise the 1 plus R to a certain power. But what you're effectively doing is that you're raising it to the power of the time point you are calculating it. Okay, so if you are calculating the future value of $1 2 years from today, or 2 periods from today, you're going to raise it to the power of 2. If you're calculating the future value of $1 1 period from today, or 1 year from today, you're going to raise it to the power of 1, right? So that's the power. Okay, so I think if you look at the third one, what do we get? We get something very similar. We begin with PV, and this is PV times 1 plus R to the power of 1. This is PV times 1 plus R to the power of 2, right? And the last one should be PV times 1 plus R to the power of 3, okay? So we can find matchings, and matchings. Okay, so we wonder, what about this one? What's going on with the first one? I can say this is PV times 1 plus R to the power of 0, right? So when you raise anything to the power of 0, you get a 1, right? You get a 1, so this is it. So we are calculating the value of a certain amount of dollar at any time point given a return, 20% in this case. You just need to use this formula. That is, it is the present value times 1 plus the return raised to the power of the number of periods, okay, between today and the periods you are trying to calculate. So we can try to, make it a more general term where we have a year t. So basically t years later. So we are standing at time 0. So 1, 2, 3, 4, and the t. So if I put $1 in, how much money should I get with a 20% return? If I put $1 in, I should get 1.2, 1 plus 20%, which is 1.2, raised to the power of t. I should have this amount, okay? Okay, so this is the future value, okay? And I have to call for attention, that is, this t is not just t. This t is essentially t minus 0. Okay, so this is the last period minus where you begin your investment, where you start. So let's look at this case. Let's put it into perspective. Let's assume capital T. Let's assume T is 4. Okay, so we should have 0, 1, 2, 3, 4. If I put $1 in here, at the end of year 4, I should get 1.2 to the power of 4. Okay, but if I begin like here, so times 0, 1, 2, 3, 4. Let's say I don't have $1 right now. I'm gonna say I'm gonna invest this $1 a year from today. Then how much am I gonna have at the end of year 4? Okay, is it the same as this? Actually, no, it's not gonna be the same, because from time 0 to time 4, there has passed year 1, 2, 3, 4. So from time 0 to time 4, 4 years has passed. But from time 1 to time 4, only 3 years has passed, right? So 1 year, 2 years, and 3 years. Only 3 years has passed. So the value we're gonna get is 1.2 to the power of 3. Okay, it's 1.2 to the power of 3. So which is equivalent to 1.2 to the power of 4 minus 1. Okay, the ending period minus the beginning. Okay, so this is the future value. So we have the formula, a more general formula for that. Okay, we have that is the compounding formula to get R0t. So I need to explain this a little bit. So R0t is the return if you were to invest from time 0 to time t, okay, with a per year return of, let's say, 20%. So if that's the case, what did we do? So if you look at the previous slides, if we put $1 in at the beginning, in the end I should get 1.2 to the power of t, right, minus 0. So the R0t should be 1 plus the R, which is 20%, raised to the power of t, right, and minus 1, right? So this process is called compounding. This process is called compounding. So you should be able to read the posted PDF file to get better understanding. Okay. And then if the 1 month interest rate is 1%, what is the 1 year interest rate? So within a year, there are 12 months. 1, 2, 3, 12. Okay, there are 12 months. So for every period, you get 1%. Okay, so what's the 1 year rate? So what do you get? So what you're gonna get is like this. So you're gonna begin with $1, right? So assuming you're gonna invest $1, and then 1 month later, you get 1 plus 1% times $1. Then another month later, you have this, right? So this whole thing is your beginning of month 2, which is here, right? At the beginning of month 2, you have this much, but at the end of month 2, you have a total of this much, right? So what you do is you keep going, and until the last month, which is month 12, right? So this is number 1, number 2, then this is number 12. So this is equivalent to 1.01 to the power of 12. So in the end, you're going to have this much. Okay, in the end, you're gonna have this much. So how much is this? This should be 1.126825. Okay, so again, this is in dollar. Okay, this is in dollar. So this is saying if I put up $1 at the beginning of the year, right? So $1 here, I'm gonna be able to receive 1.126825 dollars, okay, at the end of the year, okay, given monthly compounding. So basically, this is basically saying for every month we have interest, and then at the beginning of the next month, I'm gonna count the interest in. So this change, how much return am I getting? I'm getting 1.126825 minus 1, right? Because I put up $1 to get 1.126825. So for every dollar, I'm getting 1.126825 in the end. So what's the return? What's the rate of return? We just need to use it to minus 1, which is 0.126825. Okay, so which is 12.68%. Okay, so this is a 1-year rate. So I hope I'm clear about this relationship, because this is where I find most trouble. So, and that's also why I have this. So the minus 1 is here, right? So as you can see, the minus 1 is here. So the minus 1 is because the idea of 1.126825 is that for every dollar you're investing, you're getting this much, right? So to calculate the return, the percentage return, what we did was that we can first calculate the dollar profit, 1.126825 minus 1, and then this is the dollar profit, right? 12.6825, then divided by 1, right? So the division by 1 doesn't really make any difference. So this is equivalent to 1.126825 minus 1, right? 6. So which is 12.68%. Okay, so this minus 1, there are many ways you can understand this, but you can either understand it as, just managing the initial $1 investment, or you can think about it as just minus 1, because 1.126825 is already for every dollar. Okay, so that's the formula. So the idea of this part, for all we have talked about, is that we're trying to get the idea of compounding in our mind. So basically, what is compounding? So compounding is basically what we have been doing. So we were calculating end of investing period value, while assuming that at the end of each period, the interest is calculated. So if you look at these two, so at the end of year 1, which is the beginning of year 2, so this horizon, right? At the end of year 1, which is the beginning of year 2, we are using the principle of $1.2 to calculate the year 2 ending value, right? We are not using the principle of $1, which is our true principle. So what's going on here is that as the periods goes by, for every period we're moving on, this we are counting the interest we earned from the previous period as the principal for the upcoming period. So in the first period, from time 0 to time 1, we have a principal of $1, right? That's here, and we have a interest of 20 cents, right? So in total, we have 1.2 cents. So this total amount is used at the beginning of period 2, where we use the $1.2 rather than 1, which is the principal. 1.2 is the total of principal and interest from the first period, to calculate the 1.44, which is the ending value or the future value at the end of period 2. Okay, so this is called compounding, interest compounding. So basically we're counting interest from the previous period as our new principal at the beginning of the upcoming period. Okay, so the compounding is achieved by using powers. Okay, by using powers. Okay, okay, so we can also turn around and figure out the return. So if I invest $5, sorry. So here I need to grow. So if I decide to invest in $5 and I'm gonna receive 8 in 10 years. So T equals to 10, right? So what's the annual rate of return? So basically, what's my return? What's your R? So 5, that's our initial investment, times 1 plus R. This should give us the end of year 1 future value of this 5. And if I raise it to the power of 10, it should give us the end of year 10 future value of the $5. And I have to equivalent it to 8. So this is saying at return R, with $5 initially invested at time 0, for 10 years, I can get $8. Okay, so if I initially invest $5 and I get a return of R, and I keep getting it for 10 years, in the end I should get $8 in total. Okay, so what's that R? So we just need to solve that R. So R is 8 over 5 10th root, then minus 1. Okay, so I hope you all are comfortable solving this unknown. Okay, so from this to this should be pretty straightforward for you. Okay, so if you have trouble, let me know. Okay, so this is 4.8%, so roughly 4.8. Okay, so let me look at my calculator. Okay, yeah, 4.8, roughly 4.8%. Okay, okay, so that's the the reverse of calculating future value. So you are given a present value, you are given a future value, and you're looking for R. But what you see is the same formula. So I'm gonna circle this, right? And if I go back up, you should be able to see this and this, right? The same formula. Okay, the same formula. Okay, and also same thing here, same formula. Okay. Okay, so if you want to double your money every 12 years, what is your rate of return per year? What is your rate of return per year? So for example, if I want to double my money, so basically that's saying for every dollar I put in, I should get 2. So, right, I hope we have the same definition of doubling. So, in 12 years. So you want to double your money in 12 years. What's your return? What's your per year return? So basically the same for every dollar I'm investing with a return over 12 years, right? The same formula. The present value times 1 plus the R over 12 years should be 2 times the present value. Okay, should be 2 times the present value. So I forgot to give a name of this ending period value, so this is called FV, future value. Okay, this is called future value. So change. So this is FV. Okay, this is FV. So can you solve it? You should probably be able to solve it because this is the same idea as the previous question, right? So you can try to solve it yourself, and R should be 5.95%. I hope you get the same answer. Okay. Alright. So if a project promises a return of 8%, how long does it take for you to double your money? Ooh, this is a little different. So let's say you begin with $1 and you want to get $2 in the end with an 8% return. What's the number of years it takes to double your money? What's the number of years? Right? It's the same setup. So present value times 1 plus r to the power of t equals to the future value. So 1 times 1 plus 8% to the power of t equals to 2. Great, so you can solve it. How do you solve it? You can take logarithm on both sides. So if you log this, it becomes t times log 1.08. If you log this, this is 2, so t is basically log 2 divided by log 1.08. So that's basically it. So the number should be 9. Okay, so you may wonder, do I have to use the natural log? That is the logarithm, natural logarithm? You don't have to. Okay, whatever base, as long as in the numerator and denominator you have the same base for the log, it's the same. It's okay. Okay, so it doesn't have to be the natural log. Okay, so that's the log. That's some algebra. So that's pretty much it for this video. Okay, I'm gonna pause right here, and if you have any questions, let me know. But make sure you also read the readings posted on Canvas so that you have better understanding, and then you will be able to complete the quizzes.